Okay, you can refer to your module on topic of 2.7 Impulse and Impulsive Force. Now we go through the notes first. Comparison between impulse and impulsive force. Look at the definition. For impulse, defined as change of momentum or product of impulsive force and time of impact. You still remember we have impulse J equivalent to mv minus mu or equals to Ft. For impulsive force, definition is rate of change of momentum or the rate of impulse during collision, or the large force that acts over a short period of time during collision and explosion. Okay, now we go to the formula. The formula for impulse is defined as change in momentum or product of impulsive force and time of impact. So the formula is mv minus mu or Ft. For the impulsive force, we use the formula F equals to change in momentum divided by time of impact, thus equals to mv minus mu divided by t. The SI unit, impulse is change in momentum, thus the unit same as momentum, so we use kg meter second negative 1 or Newton second. For the impulsive force, unit for impulsive force, we use Newton, N, or kg meter second negative 2. If given a graph, of impulsive force against time, then we can determine area as that equals to impulse. If we have graph of impulse against time, then gradient of the graph is equivalent to impulsive force. Okay, number 2. Magnitude of impulse increases when reaction time increases. Remember the formula, impulse equals to Ft, meaning as t increases, impulse increases. Example, kicking a ball hard with follow-through action will increase the reaction time. Impulse or change of momentum increases, causes the ball to move faster. What is follow-through action? So I hope you can go and search in the internet for more information. What is the meaning of follow-through action? Alright, number 3. Magnitude of impulsive force increases when time of impact decreases. Example, mortar and pestle is made of hard material. It will shorten the time of impact, thus increasing the impulsive force and causing the foot to crush faster. So as we discussed before, impulsive force is inversely proportional to time of impact. When time of impact is shorter, impulsive force is larger. And also remember, hard material or hard surface will shorten the time of impact. Okay, now we look at a discussion on how impulsive force is reduced, for example, in sports activity. Look at number 1. Thick and soft mattress is used in high jump event. Normally, we use a very thick mattress in order to prevent injury. But how can we explain by using concept of impulsive force? Thick and soft mattress is used to lengthen the time of impact during landing. Thus, impulsive force can be reduced so that it can prevent injury. Again, the relationship between impulsive force and time of impact is inversely proportional, meaning when time of impact is longer, impulsive force is smaller or can be reduced in this case. Okay, next. Number 2. The athlete has to bend his knees when he lands on the ground, like in long jump event. The athlete bends his knees to increase the time of impact, so the impulsive force can be lowered and prevent injury. So meaning the longer the time of impact, the smaller the impulsive force. So this action can reduce or prevent injury. Okay, next, benefit of impulsive force. or advantage of impulsive force. Meaning impulsive force can be beneficial, can be harmful, depends on the situation. Okay, look at number 1. Helmet can protect motorcyclists during accident. So explanation on this one. During accident, the helmet will made from thick and soft material inside. It will lengthen the time of impact. The relationship between time of impact and impulsive force is inversely proportional, so impulsive force will be reduced, thus reducing the injury. So it means inside there's a soft material like a sponge, so that it can lengthen the time of impact. So when the time of impact is lengthened, meaning the impulsive force is smaller or reduced. Okay, number 2 again, we discussed the pestle and mortar. Okay, pestle and mortar, this one used to crush food like chili. Mortar and pestle are made of hard material. It will shorten the time of impact, thus increasing the impulsive force. So we need greater impulsive force in order to crush the food. Okay, number 3, the use of hammer and nail using impulsive force. Hammer and nail are made of metal. When hammer hits the nail, the collision time is small or short. Hence, impulsive force becomes big, so the nail can penetrate easily. Okay, so the nail and the hammer is made of hard material, then the time of impact is shorter. Thus, larger impulsive force will cause the nail to be driven easily into the board. Okay, number 4. The taekwondo exponent smashes the wooden block. Okay. The taekwondo exponent will run with high speed, thus impulse produced is large. The time of impact during collision is short, and it will produce large impulsive force, meaning the movement is very fast in order to produce larger impulsive force. Okay, now let's look at some example of calculation problem. Uji Kendiri 2.7. You can do first, then only you can check from here the answer. Okay, number 1. A 2 kilogram metal ball falls from the building with velocity 5 meters second negative 1. What is the change of momentum of the ball if it bounces back with velocity 3 meters second negative 1? Alright, in order to solve calculation problem, as usual, you need to list down all the information given. For example, mass equals to 2 kg, initial velocity 5 meters second negative 1, the final velocity 3 meters second negative 1, and make sure you are able to detect direction, which direction is positive, which direction is negative, because here when we discuss about impulse and impulsive force, direction is very important. Okay, now look at the how we solve this problem. We want to determine impulse or change in momentum. Okay, now direction downward we take as positive, meaning u will equals to 5 meters second negative 1. The ball bounces back. The bounces back means after hit the ground, it bounces back. Thus, the final velocity is in opposite direction. So we must put negative sign. So look at here. So you substitute the value of m, 2 kilogram. V, you must put negative 3 here. Minus 2 times 5. Then we get negative 16 kg meter second negative 1. Okay. So the change in momentum is negative. Okay. meaning direction of the change of momentum or impulse is upward. Okay, it's not downward, upward. We get negative value. Okay, now we look at number 2. The diagram shows a car with mass 3,500 kg move its velocity 15 meters second negative 1 collides with a concrete wall. Okay, you can look at the diagram. Again, try to label all the information given. You can just label here on your question paper, then label the diagram. For example, M equals 3,500 kg. Initial velocity 15 meters second negative 1. So collide with the concrete wall, meaning finally the car is at rest, okay, after collision. Thus the final velocity equals to 0. Okay. Now we want to calculate part A, impulse by the car. If the time taken during collision is 0.003 seconds, calculate impulse by the car. Impulse by the car means impulse on the wall. Okay, we want to calculate impulse equals to mv minus mu. So we calculate for the car. So mass of the car is 3,500, but v equals to 0. That's why the value here is 0. Okay, minus 3,500, and the initial velocity we take as positive, so we get 15. Then the value is negative 52,500 kg meter second negative 1. Okay, so we get the value is negative, meaning direction of the impulse is to the left. If diagram here shows u is to the right, just now you take as positive value, so you get negative answer, meaning direction of the impulse is to the left. Okay, so now we want to calculate impulsive force experienced by the car. Impulsive force on the car actually is reaction force. Okay, if on the wall is action force, so on the car is reaction force. Okay, so F equals to impulse. Impulse divided by 0.003. Thus we get negative 1.75 times 10 power 7. So if we mark the direction, impulsive force on the wall is to the right. Impulsive force on the car is to the left. That's why the answer that we get is negative, showing that the impulsive force act is to the left. Okay, number 3. The diagram shows a marble move its velocity 25 meters second negative 1 after being hit by the finger. The time of impact between the finger and the marble is 5 milliseconds. What is impulsive force of the marble? Okay, so meaning initially the marble is at rest. So we use the formula. Final velocity is 25 meters second negative 1. So impulsive force of the marble, meaning on the marble. So we have mv minus mu divided by t. So here there's some step that skip here, so you can write again. F equals to mv minus mu. So you can just substitute the value here. So for mv, mu equals to 0, so we have mv only here. So 0.015 times 25. Direction to the right, take as a positive. So 5 times divided by 5 milliseconds. So you convert to second. Milli equivalent to 10 to the power negative 3. Thus you get F equals to 75 Newton. Meaning impulsive force of the marble is act to the right. Okay. the action is to the right, because the answer is positive here. Okay, same direction as 25. Okay, number 4, a shuttlecock of mass 50 gram move at a velocity of 45 meters second negative 1. Chong Wei hits it and the shuttlecock moves its velocity of 15 meters second negative 1. What is impulsive force experienced by the shuttlecock if the time of collision is 15 milliseconds? So again, you can sketch a bit. If you cannot see clearly what is explained by the question, then you can just